Consider the following infinite geometric series. Determine x such that the sum is convergent. So in order for a geometric series to be convergent, we will need to have the common ratio will have to be between -1 and +1. So r, that's our common ratio, has to be greater than -1 but less than +1. So let's get determine an expression for r in this case. So r is going to be the quotient between two subsequent terms. So it's going to be t2, term number 2, over term number 1. This here is term number 2. This is term number 1. Just plug it in. That's your second term, and your first term is simply 4. The two 4's cancel. So our common ratio r is 2x minus 7. So in order for x to be, in order for the series to be convergent, r has to be between -1 and 1. So we can write this as, so the common ratio r has to be greater than -1 and less than +1. And now we just have to solve this. We can add 7 to each term. So -1 plus 7 is 6. 2x minus 7 plus 7 is just 2x. And 1 plus 7 is 8. Divide by 2, which gives us 3, x and 4. So x has to be between 3 and 4 in order for this series to be convergent. In B, determine the infinite sum in terms of x. So here we're going to be using the formula for determining the infinite sum of a geometric series, which is the sum of an infinite series as we go to infinity equals a, which is the first term, over 1 minus r, or the common ratio. The first term here was 4, so it's just a matter of plugging that in. 4 over 1 minus the common ratio. Well, the common ratio was 2x minus 7. Like that. We can drop the bracket. So it's 1 minus 2x plus 7. Combine like terms. So it's going to be -2x plus 8. We can now factor out 2. So if we do that, we can factor out a 2 in the denominator. And I'm going to be left with -x plus 4. We can reduce. This 2 disappears. The 4 becomes a 2. And we have 2 over, and I'm going to reverse these two terms, so it's going to be 4 minus x. So that's the sum towards which this geometric series approaches as we go to infinity.